When we look at disease resistance, we can divide it into nonspecific or innate immunity and adaptive or acquired immunity. So nonspecific, and the bottom bullet point should say specific immunity. Nonspecific versus specific are both things that you have, but in innate immunity, you are born with these. They are nonspecific types of response because they do not have to be learned by your immune system. They are present at birth and include defense mechanisms that provide general protection against a wide range of things, regardless of what it is. Now, specific or adaptive or acquired immunity, all the same, these involve specific lymphocytes, kind of like we've talked about B and T lymphocytes, and they have memory cells and they can combat a specific antigen. So this is also the idea behind vaccinations. So we're going to look at innate immunity in this video, and it refers to a wide variety of body responses that serve to protect us against an invasion of a wide variety of pathogens and their toxins. So again, we are born with it. We don't have to learn this. But there are really two types. We can begin with skin and mucous membranes, which just prevent us from going to number 2, the internal defenses. Now, when we look at skin and mucous membranes, sometimes this is underestimated by students as how important it is for the immune system, but this keeps us from getting many different types of infections. Skin has tight junctions between the cells, and lipids retard lots of evaporation, so they keep us from being infected by many things out of the environment, along with mucous membranes that line the gut and the respiratory passages. Think of mucous membranes lining our respiratory pathogens that are made to catch things before they get down to lower regions. Tears will also be produced to take things out of the body, as well as saliva, mucus. They are made to expel certain substances. Cilia helps to push things out. A lot of mucus is propelled by cilia. Epiglottis, this is the covering over the larynx, prevents things from getting into lower respiratory passages. Urine flow and defecation both move bacteria out of the body, as well as vomiting when you are sick is made to expel things that are making you ill. Sebum actually has an antifungal in it. This is oil that comes out of sebaceous or oil glands. Lysozyme is a chemical in lysosomes that helps destroy bacteria and foreign particles. Gastric juice in your stomach is a low pH, and there are many viruses and bacteria that cannot survive stomach acidity unless there's a very high viral load. Now, once things get past those external defenses, then your body has some more non-specific responses that can attack things regardless of what it is, just because it is foreign. So antimicrobial proteins, phagocytes, natural killer cells, inflammation, and fever are the ones that we are going to review, the internal defenses in this video. The neat figure from a scanning electron microscope shows a phagocyte engulfing microbes, one of the most common internal non-specific defenses your body has. Now, all of these red items listed are antimicrobial substances, and that means these are things that are non-specific that help to kill microbes from the body. Interferon is something that an infected cell with a virus produces to warn other cells around it about not getting infected with a virus. So they stop replication in other cells. So it's kind of like a warning signal. We'll talk about complement later in this video, but complement proteins are things on plasma membranes and blood plasma that help complement those nonspecific responses. So it causes lysis of infected or bacterial cells, enhances phagocytosis, which is another nonspecific response, and also speeds up inflammation, another nonspecific response, or we'll say enhances instead of speeds up. There are lots of bacteria that are not able to survive in your body because they have iron sequestering behavior. This is a problem if you end up with excess iron, but you have in your body things like transferrin and ferritin that bind to free iron, not only to protect organs, but also because some bacteria thrive on iron sequestering behavior. Finally, there are peptides released in the body that kill bacteria and attract immune cells called antimicrobial proteins, which we'll speak more on later. Other nonspecific responses, there are two important types of cells. There is a lymphocyte known as a natural killer cell, and that makes up 5 to 10% of lymphocytes in your blood. The others are B and T cells, and they're involved in specific or acquired immunity. And phagocytes. Natural killer cells tend to be less common in blood, and they tend to live in lymph nodes, bone marrow, and the spleen. And these natural killer cells kill infected and tumor cells. They do this by producing a protein that perforates bacterial cells, and then an enzyme that enters called granzymes that can kill the cell from within. Phagocytes are cells such as neutrophils and macrophages, which are white blood cells that live in immune system organs and in your bloodstream. And what they do is ingest and destroy debris or microbes. Now, if we see the figure here, we can see the stages of phagocytosis. The first is chemotaxis, which I think is very interesting. The phagocyte will release chemicals that attract this microbe here. So the microbe and the phagocyte will come together. It will adhere to the microbe, and it will form a pseudopod around it, which I kind of think like a deadly hug. It extends its arms out, it hugs the microbe, and it forms a phagosome, which is just a little vesicle that engulfs that whole bacterial cell. Once it has engulfed it, it fuses that vesicle containing the bacteria or virus with a lysosome. And we should know from Anatomy and Physiology 1 that a lysosome is just a vesicle with digestive chemicals. You can digest and recycle the parts of that bacteria, so it kills it, and then it can even expel some of those parts. Inflammation is something that we should be familiar with, but this is a nonspecific immune response that is a result usually from damaged tissue. So we can remember some of the characteristics of inflammation by the mnemonic PRISH, P-R-I-S-H. Pain, redness, immobility, swelling, and heat. These characterize inflammation. So things that happen in inflammation. The first one is we end up with vasodilation and increased permeability. So it would be nice if there was an accident on the interstate, if that 2-lane road could just expand and become a 7-lane road to allow all the emergency vehicles to come in. Our interstates can't do that, but your blood vessels are that way because they dilate and they allow more white blood cells and immune system cells to come to the area of infection. Notice also those vessels become increased permeable. So those white blood cells can actually perform something known as emigration, see there with an E, where they can squeeze through spaces and capillaries, go out into tissues so that they can phagocytize bacteria and do their job better. And then, of course, you get tissue repair. There are many chemicals that cause this vasodilation, increased permeability, and complement of phagocytosis. Histamine is one we think of a lot. This is released by white blood cells known as mast cells. We take antihistamine sometimes to lower that inflammatory response. Kinins that cause vasodilation. Things also known as prostaglandins, lipid-based, that intensify the vasodilation and the increased permeability. Basophils are also released during allergies. These are things that also will help increase this situation. We have a video on complement later, but it just increases cytolysis, causes more inflammation and phagocytosis, so complements the things already happening. And leukocytosis is a temporary increase in white blood cells arriving to the site of infection. They're kind of like little ambulances. So the ones that arrive first to the site of infection are neutrophils because they are the most in circulation. But once macrophages get there, they arrive in larger numbers, so mostly monocytes. And finally, fever. Your hypothalamus detects in a nonspecific immune response and causes your body temperature to go up. This may be largely due to a chemical in your body known as interleukin-1, which is triggered by bacterial toxins. Now, there is debate on why we have fever. Sometimes, obviously, it can cause more problems as the body gets too warm than good, but we believe that some of this will inhibit bacterial growth sometimes with the elevated temperature. It may speed up the effect of interferon, or it may also speed up enzymatic reactions to help your body get better more quickly.